At this point, you're ready to construct a confidence interval. We're going to go ahead and consider this exercise here, where you're being asked to construct a 90% confidence interval for a proportion. This confidence interval is going to help you estimate the true population proportion of students that are registered voters. We're going to read the problem, and then we're going to label the value of X, N, and CL. For a class project, a political science student at a large university wants to estimate the percent of students that are registered voters. He surveys 400 students and finds that 300 are registered voters. Compute a 90% confidence interval for the proportion of students that are registered voters. So again, here we want to take notes of the values that are given to us. In this case, X is the number of students who said, yes, I am registered to vote. We have 300 students who said they were registered to vote. Now, we also have the value of N. N is the sample size. We have 400 people for this sample. Notice it says 400 students were surveyed. Now, our confidence level, CL, is equal to 0.90. So that's all the information that is given to us. Now, let's go ahead and find the C-score. And for this, I want to make sure that you can visualize what we're doing here. Let me go ahead and draw the curve. This is the p-hat distribution, and we're assuming that this distribution follows a normal distribution. Our confidence level is 90%. That means we are wanting to capture 90% of the area here in the middle. This area is 0.90. The C-score is going to help us capture that area. How far do we have to go here on the left or here on the right? It doesn't matter which one you find. It's just that the C-score on the left is going to be negative and the C-score on the right is going to be positive. To find that C-score, you need to know the area to the left of that C-score. So we need to know the area here on this tail. That area is the same area that we have here on the right tail. Now this area here is going to be alpha divided by 2. So let's take a note of that. What is alpha in this case? Alpha is equal to 1 minus CL, which is 0.90. Alpha divided by 2. Now, alpha divided by 2 is equal to 0.10 divided by 2. That is 0.05. Alpha divided by 2, which is 0.05, is the area here on the left tail and on the right tail. Now that we have alpha divided by 2, which is the area to the left of the C-score we're trying to find, we can go ahead and use technology to find the C-score. If you're using a calculator, you're going to use the distribution IMV norm. Then you're going to need to enter the area to the left of the C-score you're trying to find. That is alpha divided by 2, 0.05. Then the calculator is going to want you to enter the mean and the standard deviation of the distribution. Now you might be thinking, I'm going to have to find the mean and the standard deviation of the p-hat distribution. And we actually don't have that, right? Because the mean of the p-hat distribution is p, the population proportion. Now, because we're dealing with a C-score, your mean is going to be 0 and your standard deviation is going to be 1, right? We're talking about a C-score. A C-score is found under the standard normal distribution. The standard normal distribution has a mean equal to 0 and a standard deviation equal to 1. Now, if you're using Google Sheets and Excel, you're going to use norm INV, and you're also going to enter the area to the left of the C-score you're trying to find, the mean, which is 0, and the standard deviation, which is 1. Okay? Now, let me emphasize this. Whenever you're finding the C-score to construct a confidence interval for a proportion, you're always going to have 0 and 1 for the mean and the standard deviation. Again, why? Because we're talking about a C-score. Go ahead and find the C-score using the technology of your choice. You should be getting the C-score equal to negative 1.644885366 using a calculator. If you're using Google Sheets and Excel, you might have more values after the decimal. And as I mentioned before, those values are not going to make a difference because they're far away from the decimal point. Now, are we ready to calculate the margin of error? To calculate the margin of error, we take the C-score times the square root of p-hat times q-hat divided by n. Now, at this point, we have the value of the C-score. We have the value of n. N is 400. But we don't have the value of p-hat and q-hat. So let's go ahead and find those values. Here, P hat is the proportion of people that said they are registered voters. To find P hat, we take X divided by N. That is 300 divided by 400. This should give you 0.75. Now, how do we find Q hat? Q hat is the complement of P hat. To find Q hat, you can take the number of people who said they are not registered voters divided by the total number of people. If 300 out of the 400 said that they are registered voters, then that means 100 of them are not registered voters. Okay? So to find Q hat, we can take 100 divided by 400. However, there's an easier way of calculating this. You can simply take 1 minus P hat. That is 1 minus 0.75. That is going to give us 0.25. If needed, go ahead and take a few notes. Remind yourself that P hat is equal to X over N. And remind yourself that Q hat is always equal to 1 minus P hat. Now, if we come back to the margin of error formula, we can see that we have everything we need to calculate the margin of error. Why? Because we have the C-score, we have P hat, we have Q hat, and we have N. So here we have the margin of error formula. We're going to replace the C-score corresponding to alpha over 2, with the C-score we found in step 2. Here's the value of the C-score. Now, let's replace P hat with the value of P hat. The value of P hat is 0.75. Now, let's replace Q hat with 0.25. Finally, we're going to replace N with the value of N, and here is 400. This is the expression that you can enter on a calculator. When you enter this expression on your calculator, you should be getting negative 0.0356121256. Now that you have the value for the margin of error, you're ready to construct the confidence interval. When constructing the confidence interval, go ahead and focus on finding P hat minus E, then find P hat plus E. With those two values, you can go ahead and construct the confidence interval. Okay. Remember, you have P hat. P hat is 0.75. To find P hat minus E, you're taking P hat and you're subtracting the value of E. To find P hat plus E, you're taking P hat plus the value of E. Okay? So go ahead and find those values. I'm going to ask you to enter those values below this video. For this problem, I'm going to ask you to round to 4 decimal places. Now, once you have the confidence interval, you should be able to write a sentence to interpret the confidence interval. Here, I'm going to go ahead and copy the sentence that we had here above. I want to show you how you can reuse this sentence for different problems. Here, we're going to say that we estimate with, what's our confidence level? Our confidence level is 90. So we're saying we estimate with 90% confidence that the true population proportion is between, and I don't have the values here because you're going to be computing those values above. So you can enter those values once you're done computing the confidence interval. Now, what we are going to do, we're going to make sure to describe the population proportion. What does this value represent? Let's go back to the problem. The population proportion is the proportion of students that are registered voters. So I'm going to go ahead and copy this. We are saying that the true population proportion of students that are registered voters is between blank and blank. Once you have the values of the confidence interval, you can come back and you can complete the sentence.